In 1942, Dr. Einstein was teaching a class of senior physics students in Oxford University. So one day, he gave an exams to the class and handed the exam question paper to the assistant. So assistant received the exam, looked at the paper and questioned, Dr. Einstein, isn't it the exactly same question you gave to the exactly same class of students last year? Yeah. He was quite puzzled. So Dr. Einstein said, as you said, yeah, exactly same questions to the exactly same class. Now the assistant is even more puzzled. So then he asked, how could you do that, Dr. Einstein? How could you give exactly same exam to exactly same students 2 years in a row? Well, Dr. Einstein said, questions are same, but answers have changed. My name is Mohammed Sajid, and I'm a cloud solution architect. I work for a big organization called PricewaterhouseCoopers, or PwC in short. And I have a great interest in domain-driven design, distributed systems, big data, and IoT. And you can reach me at my Twitter and LinkedIn. Mostly I use these two platforms, so if you have any questions. And today, we will talk about the new answers. So I'll give you 2 new answers today. So I believe in continuous learning, like I never stop learning. And this is exactly what I want from you as well, like don't stop learning. Keep try to find new answers to the problems that are solved today, so that you can get better answers in future. All right? So we will talk about event sourcing system. So before doing that, I just want to ask, like, how many of you are Azure developers? You can raise your hand. Don't feel shy. I know a lot of people are not Azure developers here. Yeah. I think that will you're more relevant. 1 person, 2 persons. I think I saw a couple of people. Great. So how many of you have actually developed an event sourcing system, and that event sourcing system is running in production? Don't worry about Azure, like any event sourcing system, I mean. So raise your hand. It's okay. Yeah, quite many people, like I think 10% people, which is quite a lot. Like I have seen people don't work on these type of systems a lot. And yeah. But how many of you actually interact with an event sourcing system almost every day? Which system do you interact with?
I'm assuming most of the applications I use have event sourcing systems.
Yeah, but I can guarantee you, almost all of you, majority of us actually interact with an event sourcing system almost on a daily basis. Source control system. I heard somebody said source control system. Exactly. So when you work with Git, it's an event sourcing system. So event sourcing system is an approach in which state of an application, we do not save the state of the application, we save events we save all the changes that are happening to the state of that application. So we never store active record. We never store like, okay, what is the last value? We always keep on saving all the events that are happening in between. So in mature industries like banking, finance, law, we always have to develop systems like that. We cannot actually avoid it. It's not a choice anymore. If you need a strict audit requirement in an industry, for example, banking, finance, and other industries like that, you have to build a system that is totally event sourcing. So whether you like it or not, you have to build that kind of system. So event sourcing systems actually give us a complete log of changes. We can trace it. And most importantly, they are quite easy to debug. Let's say you have a problem in production. What happens? How difficult it is to actually debug a problem that is happening in production but not in your development or acceptance or test environment. So in an event sourcing system, what do? You actually pick up everything you have in production, put it in the development environment, and replay all these events. You will know all these terms very soon. And then it's very easy to actually debug the problem. So I call it death of cannot reproduce. Similarly, event sourcing systems are highly scalable. I mean, this is something we achieve using CQRS, if you are aware of CQRS, command and query responsibility segregation pattern. So with CQRS, we also get scalability. So we have write side where we write events. Generally, we have a different database for writing events and totally different database for actually reading those events or the queries. So we do, when we actually transform an event to a query, we actually shape it in such a way so that query becomes quite easier. So this we generally call materialized views. So if we look at a banking example, I'll take banking example because I think most of us can relate to banking quite easily. So if we talk about banking, so let's start with the balance. You have 100 euros or dollars or whatever currency you're working with. So if you have $100 and you deposit $10, so what happens in a banking system? You do not actually store or change the value of the balance. What you do, you actually store a new event. The event is called deposit performed. And if you do it one more time, actually, you have another deposit. So this is one more event that you store in your event store. And again, if we do a withdraw, what happens? We actually store another event and we call it withdraw perform event. But the bank system does not know about our balance at all. So how do we get the balance? So what happens? Bank systems, they actually replay all these events and then get the balance for us. If you look at the balance, we started with the 100, and actually we ended with the 100 as well. So if we are working with a non-event sourcing system, we will never know what happened between, all right? We will never know if this balance is a result of 2 deposits and 1 withdrawal or what happened. We don't know. Or maybe nobody actually interacted with the bank system during that time. So event sourcing systems actually answer the unanswerable. They give us answers to the queries that we even don't know today. So that's why, once more time, I will say, find new answers to the old problems. So imagine in future if we have a system that is more capable than the system we have today, and if we have an audit log of all the events, how easy it is to get new insights, new information, how easy it will become for the business leaders to do better business decisions in the future. So in an event sourcing system, we need 2 important things. When you build any event sourcing systems, I'm sure people who raised hands earlier, they know what are these 2 things. First thing is strict message ordering. That means you cannot have events out of order. You cannot actually withdraw before sending a deposit or the other way around. So your events must land in your event sourcing system in exactly strict order. That is the first requirement. And now I will ask you a question. How many of you have developed a perfect thread-safe code, especially C# and Java developers? How many of you are Java or C# developers? I worked with C#, so quite many. So have you developed or write a code that is perfectly thread-safe? Daniel, only one person I can see who wrote the code perfectly thread-safe. But yeah, I think most of us actually struggle writing a perfect thread-safe code, depending on the programming language we are working in. Some programming languages has better functionality to write such kind of code. So if we cannot write a good thread-safe code in a single process system or a single application or a monolith, how do we expect us to write a good thread-safe system or a code in a distributed environment or a distributed system? That gets even more difficult. It's not very easy. So that's why the answer to the first question, like strict order requirement, I will show you what are the durable entities, or entity functions we call them. So these are tiny services. These are like actors. Anyone worked with actor programming model before? So in actor programming model, we have state, and then we send some kind of commands to those actors. So only that actor who is a custodian of the state can actually manipulate or mutate that kind of state. So nobody else from outside, like client or other actors, other entities you call them, they cannot actually mutate or modify the state from the outside. It's only that actor who owns that state can actually do something with the state. So entities are like actors. So they communicate with each other via messaging. So messaging is, other name of messaging is signaling. So that means when a client or another entity calls another entity, you send a message, you don't wait for the response. You immediately get back 202 accepted. Now it's up to the entities, like how they want to process that message. So entities or actors, in our case, entities actually are inspired by the actor programming model. They are not exactly actors, but they are inspired by the actor programming model. So what these entities do, these entities actually are the custodian of the state. Since nobody can change them from outside the entity, like premises environment, so these entities has a concept of mailbox, or actors also has same concept. So in mailbox, you receive a command, all right? So you receive a command, okay, deposit $10, it goes to the mailbox. You do not go and change the state in the entity. Actually, entity has the control of changing the state. So when you deposit $10, the entity receives that command, does some kind of validation, and then process it, and then change the state if the entity wants to. It's up to the entity if the entity wants to change the state or not anybody from outside. So how does entities work? The entities work completely serially. They have like no concept of working with two messages at the same time. They always pick one message at a time. So they pick first message, process it, change the state if they want to, or just reject the command. So command can be rejected. So command is some kind of intent that a system or a user actually gives to another system. So in this case, the system or the thing we are working with is an entity. So when we give them some intent, okay, can you deposit $10? So it's up to the entity, okay, yeah, I can deposit $10, no problem. But if you have an empty account, imagine you have an empty bank account and you try to perform a withdrawal. Should the entity or should the system accept this kind of command? No. So what do? Commands, when you send a command, commands get validated, and then entities or actors generate one or more events out of those commands. So events are generally facts. You cannot change an event. Event cannot be like modified once it is persisted in the event store. So similarly, these entities keep on picking one command at a time. If command is valid, they will execute it and then make one or more event. So usually it's one event, but you can have more events depending on your system you're working with. So that is where we work with entities. But what happens if you have a lot of commands? What you will do? Your entities, if your entity picks one message at a time, obviously it's a slow process, it's because it's a serial. So what happens? You will process one message, it might take a lot of time. So how do you overcome this problem? You actually design your system in such a way, like rather than one function processing millions of messages, you create millions of functions, each processing one message at a time. So that is the answer to the first question, how do we achieve a strict order, like serial processing of the messages? And that we will solve with these durable entities or entity functions. So each entity function has a state, and these entities are always there. They never die, actually. If you know about South Park, Kenny never dies. So these entities actually never die. When you want them, they're already there. So we don't have a responsibility to actually hydrate or dehydrate these entities. So entity is always like hydrated from the memory into the memory using this database they're using behind the scene. So the framework takes care of it for us. So they are always there. You cannot destroy them, kind of. Yeah, you can destroy the state, but they follow virtual actor pattern. So as I said, entities have state. Entities can actually work on that state. And how do they work on that state? How do you send a message to an entity? You actually address them some kind of entity ID. So entity ID is entity name and the key. Very simple. Similarly, as I mentioned, the most important why we are thinking about using entities for this type of functionality or building event sourcing system because of the serial order. So they always execute serially. there is no chances of actually corrupting state because two people or two entities or two clients are trying to access exactly same data. So we will never have a situation where we have inconsistent data. So no race condition at all. It's not possible. And these type of entities, they actually never deadlock. So how do we actually create an entity? So the class you see here, it's not a code snippet from a big application. It is the complete solution, actually. It's a complete code. So this is how you define an entity. So entity is just like any other C# class. If you work with C#, you can actually decorate with certain properties. For example, how to serialize it, because you can control the serialization mechanism when you do that. So in this class, you actually see an entity that performs some kind of toggling. So if you think of an IoT solution, for example, you have a light bulb or something that you want to turn on and off. So what do you do generally? If the bulb is on, you just turn it off. If it is off, you turn it on. So it's just a toggle mechanism. So in this code, what I'm doing, so I'm keeping a state. So state is actually a property. It could be one or more properties. But in this case, I'm just using a Boolean that is a property. And this is the method that will actually mutate the state, all right? So who will call this method actually? Other entities and the clients. They can call this method, and then this method decides what you want to do with this command. This is a command. So once the command is there, this method can validate and perform some other actions. So the code you see it in the end, actually this is just a glue code. This is how Azure Function Runtime actually dispatches messages to this entity, all right? So don't worry about it. And I have a different way of actually coding it. If you know about partial classes in C#, actually you can remove this and put it in another class, which is a partial class. Then with the magic of compilation, .NET Framework or system, they actually merge it into a single class. So this is how easy. So right now you already have a complete entity which behaves exactly how I explained. It's a complete actor-style entity, right? So these entities actually, they work on the durable task framework. So durable task framework actually comes with the built-in HTTP endpoints that you can use to actually call these entities. So you do not have to build wrappers around them, or you don't have to build more code to actually reach to these entities. These are very easy. So the durable task frameworks actually brings these APIs to us. So batteries are included and installed and always running and never run out actually. And I'll show you how easy it is to actually use in the end. So what are the limitations for durable entities? So while we were talking about limitations, durable entities, they perform, the only entity can actually mutate the state. But today, there is one big problem with these type of entities. So what happens if you have an exception while trying to mutate the state? Anyone? Guess?
Hopefully roll back.
Exactly that's what I hope for. But it doesn't work like that today. So ideally, when there is an exception, after mutating a state, the state should roll back to the previous state where the function actually started, right? But in today's implementation, this is not the case. So what I'm doing, actually, I'm collaborating with a couple of people from Microsoft and opened up a GitHub issue, and almost everybody actually agreed on what I wanted, what I hoped for, or what you hoped for exactly. So this is totally unexpected behavior. So I thought maybe it's some kind of glitch or something in the framework that I'm using. Maybe I have to upgrade or something like that. But that was not true. Actually, it was exactly what they have built it like. So now in the end, and this is happening during last week. I'm not talking about something like 6 months. So this is pretty new answer to the old problems, or maybe the new problems as well. So they are talking about actually improving this very soon, and we have been discussing it a lot. So yeah, but in future releases, that will be rolled back, all right? And durable entities actually prefer durability over performance. So if you have a strict latency requirement, you should not use durable entities or entity functions. So be aware of these type of state mutation problems today. Maybe not in future, maybe not in next week. When Microsoft will release a new version, we might not have this problem. But today we have this problem. So you just need to make sure you mitigate it. You have to implement a rollback logic yourself today. So as I said, entity-to-entity communication happens via signaling. So signaling is also called messaging. That means you will send a message, you will get a response, 202 accepted. It will not wait for the entity to process the message and then respond. Right? So it's an eventual consistency. Not ideal for applications that require strict latency, because entities prefer durability over latency. So it will be a little bit slower as compared to like sending the request response quite fast. And request response pattern is possible via orchestrations. Azure Function has another concept called orchestration functions, which I will not talk about today. So they are only the request response is possible only via orchestration functions. So second, actually, piece of the puzzle is transaction. So in every event sourcing system, you need a strict message order, but then you need a transaction behavior. Why do you need a transaction behavior in an event sourcing system? It's what happens when you write an event, you might be able to write, you might want to write more than one events at a time. And you cannot be in a state where one event gets persisted and the other gets failed, or there is some kind of exception. So you need a transactional behavior. In the classic days like SQL Server or other databases, you had this transaction behavior. But when we talk about cloud-native solutions, cloud-native databases like Cosmos DB, DynamoDB, they are really distributed and they give you like massive scale. You cannot even imagine that from like probably 10-year-old database. But what is the downside? They do not support transactions across the partitions. So partitioning is the technique how these type of databases actually scale out. So you create multiple partitions, so they scale out, they keep on adding more partitions. So Cosmos DB and any other database like that, they actually give you transaction support, full asset transaction support on a partition level. So transactional batch actually is a technique that gives you like this kind of transaction behavior, but from the SDK, not from somewhere else. Cosmos DB always had partition level asset transaction support. But we had to write JavaScript, stored procedure, and call it to actually have that kind of functionality. Otherwise, there is no way to actually update or insert multiple documents in Cosmos DB in one single transaction. So transactional batch is a group of operations that need to go as a group. So either all of them will succeed or none of them will succeed. So very simple. So imagine a movie ticketing system. So you're booking a movie tickets, you want to book 3 tickets, and all of them are events. So what happens? You select 3 seats, like you want to sit together with your family, and you try to book. Imagine if one of the ticket doesn't get booked. You would rather not book any ticket than actually half of your family members or one of your family members is not watching the movie together with you. So that's why it's very important to actually have a transactional behavior in any system. And in these cloud-native systems, they have transactional behaviors, but you have to use the right tool to achieve that. So how does a transaction batch looks like in C#? So what do? You actually describe the transaction batch. It's very simple. As I said, the transaction has to be scoped to a partition. So I'm using a partition here. I used my favorite movie, Frozen 2 here. So what happens when the execute batch will execute? This method you can see in the end. Actually, that will actually create this particular, that will actually save all these documents in one go. And if one of them fails, actually all of them will fail, actually roll back. So Cosmos DB will always be in the right state. So how does it work actually from the SDK? So in SDK, you describe a batch. The SDK will actually group them together into one document probably behind the scene, and then serialize it on the wire. Cosmos DB service will receive it, unpack the documents, put all of them together, and if any of them will fail, it will fail all of them. And then give us a response back using exactly same serialization protocol. So when we receive the response, we can actually get each document or each result of this transaction batch one at a time. So this is how it works. But point is why I am so fan of using transactional batch over not writing a JavaScript code. And the reason is choice of language. There are many reasons. You can have a better testability with when you write something as a code with the same type of code base you are working with, rather than writing JavaScript codes. But my favorite is actually choice of language. Why choice of language is my favorite? As Dr. Nelson Mandela said, if you talk to a man in a language he understands, that goes to his head. But if you talk to him in his language, that goes to his heart. And I'm a big fan of C#. So I write from the heart. So that's why it's important for me. So what are the limitations of transactional batch? Again, we have to think about like pros and cons. So limitations of transaction batch are, there is a first size limitation. Like you cannot have like a big giant document or a batch which is like more than 2 megabytes. Like every document is quite big. You cannot have like that. So we need to think about the payload. But anyway, if you're trying to send 5 megabytes of data on the wire, probably you have some problem in your design, so you have to think about it. Similarly, 5 seconds, you cannot execute it more than 5 seconds. So execution time on the server side should be less than 5 seconds. This is exactly like most of the like serverless systems has this type of restriction. Then we have maximum operations per batch. So even if you have a really, really small document, you still should think about like how many documents you want to save together. How big is your transaction scope? You cannot have like more than 100 documents today. Even 100 is a lot. I think you shouldn't have more than 10, I guess, in majority of the cases. Then one more limitation that I discovered is like when you try to create a document in Cosmos DB, and if you don't specify identity or ID, it uses GUID automatically. But with transactional batch, this is not possible. You do not have support for like automatic ID generation on the server side. So you have to think about generating ID on the client side. So these are some limitations of transactional batch. So I would like to actually show you a quick demo of the banking system. I hope you can see. So everybody can see that? Good. So this is a production grade implementation of a banking system. So I have a bank account, and I deposited $10 or euros before coming to this talk. And yeah, this is the only place where I really become rich when I demo it, depending on how much time I have. But I don't have much time, so I will not be that rich today. So as I said earlier, this durable task framework comes with the REST APIs. Like we don't even have to think about like making these REST APIs or wrappers around it. So what I will do, I will actually reduce it a little bit so you can see. I hope you. Yeah. So what do we do? First, we can actually check all the entities in this system, if we have any entity or not. So if we send this request, I should be able to get at least one entity because I inserted it before coming here. So that entity is my account. It shouldn't take that much time, by the way. So there must be some problem, just like any other demo, probably. Yeah. And durable entities are not that slow. So I'll just give it one more try, otherwise I'll just finish it here. So the demo I'm showing you is a bank, exactly same scenario we saw earlier. And the name of this bank is actually Generous Bank. As name implies, it's a fictitious bank. Don't worry about it. So I have never seen any bank that is generous. And by the way, we can withdraw more money than the bank has. So I don't have any checks here as well. Probably that's the reason this bank is not working. Yeah, but I can explain you a little bit while it's trying to load behind the scene. So what do I do? When I send a deposit command, so Durable Task Framework actually gives us all the controls from sending commands from here directly. For example, I can mention operation, OP, and then perform deposit. Similarly, I can send more commands from here, like withdraw amount or do other things depending on what you have implemented. So the most important thing that I wanted to show, let's see if it works, is the snapshotting. Anyone knows what is snapshotting? So in an event sourcing system, when you have a lot of events, so what happens every time when your actor or your entity hydrates, it has to reload all the events back to calculate that current balance. Do you remember? We saw earlier in the example. So what happens if you have a lot of events? So with time, your entities will become really slow, because they will actually have a really slow loading time, because then you have to load these million entities or million events into that entity. So snapshot actually create an intermediate snapshot and calculate the balance. All right? So and you can use the snapshot based on time or based on number of events depending on your use case. If you're working with banking system, maybe based on number of events. But if you're working with IoT system, maybe based on how much time. Every day you can calculate a snapshot. So the next day, when your entity will hydrate, it will actually start reading messages or reading events from that snapshot. So it doesn't have to actually load the whole, it doesn't have to actually load all the events from the beginning. All right, I think the function runtime is not loading, so we will skip that here. But I can show you how the event store looks like in Cosmos DB. So I'm using Storage Explorer that actually can show you some events. So what I'm doing here, I'm keeping one metadata document that keeps a last sequence. So if you look here, this is the schema of this event. So the actual payload actually is in here. So what do? You keep on incrementing these versions. As I said, versioning is important, and then your communication has to be really serial. And that serial communication is guaranteed via entity functions. So in Cosmos DB, we don't have to worry about it. But what happens, we use transactional batch from that entity classes to actually save these type of events into the Cosmos DB. So what do we do? In each event, what I'm doing here, I update metadata because I need to keep a record of last sequence and also next event. So I will keep on adding these type of deposit and withdrawal and all those events. And if you look at the code, this is really simple, but I think we don't have to go into detail here. It's very simple. I'm doing basic events. But yeah, that's it. I don't have anything more. Do you have any questions about this?